Where does entropy generation occur in a heat engine? Have you ever wondered why heat engines are not 100% efficient? The answer lies in a concept called entropy generation. So, where does this happen in a heat engine? Let's break it down in simple terms. Entropy generation mainly occurs during irreversible processes in the engine cycle. These processes lead to an increase in total entropy, which means energy becomes less available for doing useful work. To grasp this better, think of entropy as a measure of disorder or the energy that cannot be used effectively. In an ideal heat engine, like the Carnot cycle, the changes in entropy balance out, resulting in no net generation of entropy. However, real heat engines operate differently. They generate entropy during various internal processes. One key area of entropy generation is during heat transfer. When heat moves from a hot source to the working fluid, or from the fluid to a cold source, it rarely happens at the exact temperature of the source. This temperature difference creates irreversibility, leading to entropy generation. Another important factor is friction and mechanical losses. As parts like pistons and cylinders move, friction converts useful mechanical energy into heat. This conversion increases entropy, making some energy unavailable for work. Rapid expansions or compressions also contribute to entropy generation. When these processes happen too quickly and are not controlled, they create non-equilibrium conditions, which generate more entropy. Additionally, mixing and fluid flow can lead to entropy generation. Turbulence and viscous dissipation in the working fluid contribute to this effect, further increasing the overall entropy. As a result of these processes, the total entropy of the heat engine and its surroundings rises during operation. This increase in entropy limits the engine's efficiency because some energy transforms into forms that cannot perform work. For instance, when heat is released to the cold reservoir, the entropy of that reservoir increases more than the decrease in the hot reservoir's entropy, indicating net entropy generation. To minimize entropy generation, engineers aim to design heat engines that operate as close to reversible processes as possible. This can include improving insulation to reduce temperature differences, minimizing friction through lubrication, and controlling fluid flows to reduce turbulence. Understanding where entropy generation occurs is essential for improving the efficiency of heat engines. It also helps us grasp the fundamental limits set by the second law of thermodynamics. By focusing on reducing entropy generation, we can work towards more efficient and effective heat engines.